I'm going to be reviewing Module 4 in preparation for your test. So we're going to start with simplifying radical expressions containing I. So the first thing we're going to do is break it down as the real part times the imaginary part. So the square root of negative 80 becomes the square root of 80 times the square root of negative 1. And now I want to start breaking down 80. So I'm going to use 2 and 40. I'm going to break that down as 8 and 5. Break that down as 2 and 4. And 4 breaks down as 2 and 2. Now this is not the only way to break down break down 80. There are plenty of other ways, as long as you still get 2 groups of 2 and a leftover 5. So I'm writing the fully simplified answer. 2 groups of 2 will give us 4. The square root of negative 1 gives us I. And then underneath the square root, we still have 5. Next, we want to break down the square root of negative 175. So I'm going to start off the same way I did problem 1. Write it down as the square root of 175 times the square root of negative 1. 175 I'm going to break down as 5 and 35. And 35 breaks down as 5 and 7. So we'll have a group of 5s and a leftover 7. So we'll have 5i square root 7 as our simplified form. So next we're going to look into addition, subtraction, multiplication, and division with complex numbers. So our first example is 3 plus 2i minus 13 minus 7i. So what I'm actually going to do here is distribute the negative into the second set of parentheses, so I can then treat it like an addition problem. So we end up with 3 plus 2i minus 13 plus 7i. So 3 minus 13 is negative 10, and 2i plus 7i is 9i. Okay. In number 4, we're doing 2i times 4i minus 9. So we're going to distribute the 2i into the parentheses. So we get 8i squared minus 18i. And remember, I squared equals negative 1. So we get 8 times negative 1 minus 18i, which becomes negative 8 minus 18i. Lastly, we're going to do 2 minus i divided by 4i. So remember, when you're dividing by a monomial containing I, you can multiply the numerator and the denominator by negative I instead of 4i in order to simplify. So distributing in our numerator, we get negative 2i plus I squared all over negative 4i squared. And we know that I squared equals negative 1, so our numerator becomes negative 2i minus 1. And our denominator is going to become 4, because we'll do negative 4 times negative 1, which then becomes positive 4. Next, we're going to break up our fraction. So we can write it in the a plus bi form. So we'll have negative 2i over 4 minus 1 over 4. So rewriting it, we're going to do negative 1/4 minus 2/4 becomes 1/2, and then we have our I. Next, we're going to simplify over the powers of I. So when we simplify powers of I, we have I squared, which is negative 1, I cubed, which is negative I, and I to the 4th, which is 1. Every power of I that is a multiple of 4 we'll simplify the same as I to the 4th. So number 6, we have I to the 8th. 8 is a multiple of 4, which means I to the 8th equals 1. Every other power of I would figure out how far away it is from a multiple of 4 to figure out if it's the same as I squared, or I cubed. So looking at I to the 17th, the closest multiple of 4 is I to the 16th, and it's 1 away, so it's going to be equal to I. Next, we're going to solve quadratics by factoring. In order to solve a quadratic by factoring, it has to be equal to 0. So our first example, we have x squared plus 9x plus 20 equals 0. So we are equal to 0. Our leading coefficient is 1. So we're going to look for the numbers that multiply to 20 and add to 9, which is going to be 5 and 4. So it's going to factor as x plus 5, x plus 4 equals 0. And then we go ahead and set each factor equal to 0 to solve for x. So we subtract 5 and we get x equals negative 5. And we subtract 4 and we get x equals negative 4. Our second example is 9x squared equals 36. So my first step is going to get it equal to 0. So we're going to subtract 36 from both sides. So we have 9x squared minus 36 equals 0. So anytime I have just a squared term minus a constant, I always think difference of squares. In order to factor a difference of squares quadratic, both terms have to be perfect squares. So in this case, 9 and 36 are perfect squares, but there is also a GCF. 9 goes into 9 and 36. So to make this problem easier to factor and solve, I'm going to factor out the GCF of 9, which is going to give me x squared minus 4 in parentheses. And that's the quadratic I'm going to factor, because x times x is x squared, and 2 times 2 is 4. So that's going to give us 9 times x minus 2, x plus 2 equals 0. And then we set the factors x minus 2 and x plus 2 equal to 0. We're going to add 2 to both sides and get x equals 2. Then we're going to subtract 2 from both sides and get x equals negative 2. Now I could have factored this without taking out the GCF first. I would have gotten 3x minus 6 and 3x plus 6. And I still would have gotten 2 and negative 2 as my solutions. I would have just had to divide by 3 after adding and subtracting 6 from both sides. Next, we're going to look at completing the square examples. So in order to solve a quadratic by completing the square, you actually want to start by moving the constant to the other side. So we have x squared minus 4x plus 11 equals 0. So my first step is going to be to subtract 11. So we get x squared minus 4x, and leave a little space, equals negative 11. And now we want to make the left side a perfect square quadratic. And we do that by doing b divided by 2 and then squaring it. So b is negative 4, it's the coefficient of the x term. Negative 4 divided by 2 is negative 2, and negative 2 squared is positive 4. Now we want to factor the quadratic we have on the left side. And it's always going to factor as x, and then the operation is based upon what the sign of the x term is. So in this case, it's going to be minus, because the coefficient of our x term is a negative, and it's always going to be b over 2. So we'll have x minus, and then 4 divided by 2 is 2 squared equals, and then negative 11 plus 4 is negative 7. Now we're going to take the square root of both sides to get rid of the squared. And we'll end up with x minus 2 equals plus or minus. Now I look at the square root. So I have a negative number underneath the square root, so I know I have to have I in my answer. And 7 does not simplify, so we'll leave it as square root 7. The last step is going to be to finish solving for x by adding 2 to both sides. We'll draw right in front of the plus or minus, and we get x equals 2 plus or minus I square root 7. Our next example is x squared plus 10x minus 12 equals 0. So again, like our previous example, our first step is to move the constant to the other side. So we'll add 12. We get x squared plus 10x, and leave a little bit of space, equals 12. Now we need to do b divided by 2 squared and add it to both sides. In this case, b is 10. 10 divided by 2 is 5, and 5 squared is 25. So we're going to add 25 to both sides. And then in this case, when we factor the left side, it'll factor as x plus b over 2 squared, since the coefficient of the x term is positive. So we'll get x plus, and then 10 divided by 2 is 5, and 25 plus 12 is 37. Take the square root of both sides. We get x plus 5 equals plus or minus. And then the square root of 37 doesn't simplify because it's a prime number. So it stays square root 37. Our last step is going to be to subtract 5 from both sides. And we get x equals negative 5 plus or minus the square root of 37. So next we're going to take a look at solving by the quadratic formula. So just kind of a refresher, quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. In order to use the quadratic formula, the quadratic has to be equal to 0. So our first example, we have 3x squared minus 8x minus 12 equals 0. So we can go ahead and identify a, b, and c to plug into the quadratic formula. So we have a is 3, b is negative 8, and c is negative 12. So we end up with negative 8 plus or minus the square root of negative 8 squared minus 4 times 3 times negative 12 all over 2 times 3. Negative 8 is going to turn into a positive 8, plus or minus. When we square negative 8, we get positive 64. And then negative 4 times 3 times negative 12 is positive 144 all over 6, which then becomes 8 plus or minus, and then 64 plus 144 is 208. Now we want to simplify our square root. So 208 is not a perfect square, but we can break it down. So it is 4 times 52. 4 is 2 and 2. 52 is 2 times 27. Sorry. 2 times 26. 26 is 2 times 13. So we do have two groups of 2. So we have 8 plus or minus 4 square root 13 all over 6. And then our last step is to simplify our fraction. So 8, 4, and 6 are all divisible by 2. So we get 4 plus or minus 2 square root 13 all over 3. So our next example is a little bit trickier because we have x times x minus 3 equals negative 5. So not only is it not equal to 0, but it's not set up like a quadratic. So our first step is to actually distribute the x into parentheses. So we get x squared minus 3x equals negative 5. Then we'll get it set equal to 0 by adding 5 to both sides. So we get x squared minus 3x plus 5 equals 0. Now we can identify a, b, and c. A is 1, b is negative 3, c is 5. Plugging into the quadratic formula, we get negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times 5 all over 2 times 1, which then becomes 3 plus or minus 9 minus 20 all over 2, and then 9 minus 20 is negative 11, so 3 plus or minus the square root of 11 all over 2. And the only thing we can do in simplifying our square root is write the I in front representing the negative underneath the square root, because 11 does not simplify otherwise. So our final answer is going to be x equals 3 plus or minus I squared 11 all over 2. Number 14 asks us what the discriminant of the quadratic x squared plus 5x minus 1 equals 0 is. So remember, the discriminant is the b squared minus 4ac from the quadratic formula. And it tells us what types of solutions we're going to get from the quadratic without solving it. So if I identify a, b, and c, a is 1, b is 5, c is negative 1. When we plug it in, we have 5 squared minus 4 times 1 times negative 1. 5 squared is 25, and then it becomes plus 4, which is 29. So based on this discriminant, we want to figure out what types of solutions we'll get. Either 2 complex, 1 rational, 2 rational, or 2 irrational. So the type of solution we get is based on what the discriminant is. So we only get 2 complex if our discriminant is negative. We get 1 rational if the discriminant is 0. We get 2 rational if the discriminant is positive and a perfect square. And it's 2 irrational if our discriminant is just positive. So looking at 29, it's not negative, it's not 0. It is positive, but it's not a perfect square. So that leaves us with 2 irrational solutions. So remember, complex are solutions that are going to have I in the answer. 2 rational are when you're either going to get 2 whole numbers, 2 fractions, or a whole number and a fraction. And then 2 irrational is when you have a square root still in your final answer. 1 rational is either 1 whole number or 1 fraction. It just gets repeated. The last part of Module 4 was using Desmos to pick out key information about quadratics. So you will be able to use Desmos on your test to find the information. Now sometimes some of the information is given to us based on the form that the quadratic is already in, but otherwise we'll want to use our graph. So we're going to graph y equals negative, and then in parentheses, x minus 3 squared plus 4. So if I'm looking, I know already that this is vertex form for my quadratic. So I can figure out the direction the quadratic opens and where the vertex is, and also the axis of symmetry. A asks for the x-intercepts or roots of the quadratic. So I'm definitely going to want to look at the graph for this information. So if we look to where the quadratic crosses the x-axis, it crosses at the points 1, 0, and 5, 0. Next, we want the y-intercept, so where it crosses the y-axis, which is at 0, negative 5. Next, we want to know the vertex of the quadratic. So the vertex is either your maximum or minimum point, depending on what direction your quadratic opens. Because of the negative in front here, I know the quadratic opens down, which means my vertex is going to be the high point. So because our quadratic is in vertex form, I can actually identify the vertex straight from the equation. So when we are given in quadratic in vertex form, the x value from the vertex comes from inside the parentheses, and the y value comes from outside. So you always do the opposite of what's in the parentheses. So we have x minus 3, so we'll have a positive 3, and then a positive 4 on the outside, so positive 4. My vertex is at the point 3, 4. And you can always use Desmos to help verify that you have identified the vertex correctly. And then lastly, we want to know what the axis of symmetry is. So the axis of symmetry is where your quadratic gets split in half. So the axis of symmetry is the equation, it's the vertical line that splits your quadratic in half. And that always happens at the x value of the vertex, which is at 3. So we have to put x equals 3. The axis of symmetry is an equation. We do want to make sure we include the x equals. So our second example, we're looking at the graph of 4x squared minus x minus 14. Now this is standard form of a quadratic. So the key pieces of information we can pick out from this graph are the direction it opens and the y-intercept. So we're going to start with the x-intercepts or the roots. So x-intercepts are going to be at negative 1.750 and 20. You are allowed to have decimals for the roots here. They're not always going to be whole numbers or even nice decimals, so it is okay if you write decimals for your answers. The y-intercept, so when we are in standard form, the y-intercept is always the constant at the end, which in this case is going to be negative 14. So my y-intercept is at 0, negative 14. Again, something that you can use Desmos to double check. Next, we want to identify the vertex. So because my quadratic opens up, I know my vertex is a minimum point. And the vertex here is actually really close to our y-intercept. So you might have to zoom in a little bit. And we get 0.125, comma, negative 14.063. And then for our axis of symmetry, x equals the x value from the vertex, 0.125. So let me know if there's anything from Module 4 that you still have questions over before the test.